Section 1.2, Describing the Physical World. To learn how the world works, we start by describing exactly what we see and do. We can use three basic ideas to begin describing the world. 1. What things are made of, matter and energy. 2. Where things are, in space. And 3. When things happen, in time. 3 useful ideas. Matter has mass and takes up space. In other words, matter is stuff. Energy is harder to pin down. Think about the changes you see every day. A thrown ball speeds up, then slows down. Air gets warmer and colder. Water flows downhill. What explains these changes? The answer is energy. Energy is how the universe changes. A fast ball has more energy than a slow ball. Warm air has more energy than cold air. Water at the top of the hill has more energy than at the bottom. Up, down, right, left, forward, and backward are the three different directions of space. To completely understand the motion of a ball, we need to know its exact path as it moves through space. For example, 1 second after its tossing it, the ball might be 2 meters in front and 1 meter up from your chest. 1 second later, it will be in a different position. In the laboratory, you will usually measure mass with a balance. The balance displays mass in grams. For example, the balance in Figure 114 shows the mass of 6 steel nuts to be 96.2 grams. Balances are sensitive and delicate instruments. Never drop things onto a balance. Set them down gently. In any calculations, you will need to convert mass from grams to kilograms. To convert to mass measured in grams to kilograms, you need to divide by 1,000, since there are 1,000 grams in a kilogram. In the example shown in Figure 114, 96.2 grams is equal to 0.0962 kilograms. And distance. Distance is measured in the units of length. Some of the commonly used units of length include inches, feet, miles, centimeters, kilometers, and meters. The metric, or SI system, uses millimeters, mm, centimeters, cm, meters, m, and kilometers, km. The units in the metric system are based on multiples of 10. There are 10 millimeters in a centimeter, 100 centimeters in a meter, and 1,000 meters in a kilometer. Almost all the fields of science use the metric units because they are easy to work with and are used around the world. When measuring, it is important to always say or write the unit that you are using. Without a unit, measurement cannot be understood. For example, if you are asked someone to walk 10, she would not know how far to go, 10 feet, 10 meters, 10 miles, or 10 kilometers. They are all 10, but the units are different, and therefore the distances are also different. Units tell us how to understand numbers. Without units, we don't know what the numbers mean. A stick is a good tool to use for measuring ordinary lengths in the laboratory. A meter stick is 1 meter long and is divided into millimeters and centimeters. The diagram in Figure 115 shows a meter stick along with the objects of different lengths. Can you see how the meter stick is used to measure the length shown for each object? Is very important in physical science. The concept of next and before involve time. We often want to know how things change over time. For example, a car rolls downhill over time. A hot cup of coffee cools down over time. The laws of physics tell us how things change over time. Time is used two ways. Figure 1.6. One way is to identify a particular moment in the past or in the future. For example, saying your 18th birthday party will be on January 1st, 2010 at 2 p.m. identifies a particular moment in the future for your party to start. This is the way time is usually used in everyday conversation. The second way is to describe a quantity of time. For example, if a class lasts for 45 minutes, then 45 minutes is a quantity of time. The question, how much time, is really asking for a quantity of time. A quantity of time is also called a time interval. A microwave oven with a built-in clock, Figure 117, displays both kinds of time of day, and time intervals. Any calculation involving time that you do in class will always use time intervals, not time of day. Problems in science use time in seconds. For calculations, you may need to convert hours and minutes into seconds. For example, the timer left shows 2 hours, 30 minutes, and 45 seconds. To find out how many seconds this is, convert the hours and minutes into seconds. There are 60 seconds in a minute and 60 minutes in an hour. So there are 3,600 60 times 60 seconds in an hour. So 2 hours is equal to 7,200 seconds. 30 minutes is equal to 1,800 seconds. Therefore, 2 hours, 30 minutes, and 45 seconds equals 9,045 seconds. Pause here and answer these questions.